Hello, and welcome to the first episode of Hands of Science. Hands of Science will be a web-based series in which I describe areas of science, geography, possibly history, from my unique perspective, and using only my hands. This isn't going to have a lot of numbers, not going to have a lot of technical things, it's just going to make an increased understanding of the world of science, history, and geography. Today's episode is electromagnetism. Alright, so electromagnetism, what is that? Well, it's one of the four fundamental forces in the universe. Those four forces are the strong force, the weak force, gravity, and electromagnetism. Notice I did not say that we're doing hands of spelling. So, a lot of people know two of these forces. Gravity and electromagnetism. Strong force and the weak force, they're involved in keeping atoms together, they're involved in radiation and a lot of other processes. We're not going to talk about them today. Obviously, I did talk about electromagnetism, that is the topic, but we will also talk about gravity. Because all the forces are related, they all interact. So you really can't talk about one in exclusivity. Let me clean this. In case you're wondering, I'm using water-soluble oil pastels to write on this tile. Why? Because look how easy it is to clean and reuse the tile. Why hot pink? That was simply the first one I grabbed. Alright, so we'll put this aside. We'll do our demonstrations. Okay. I have three things right here. You might be wondering what these three things are. This is a fake hearing aid. This is a hearing aid battery. It is real. This is a hearing aid cleaning tool. What these actual things are, not all that important. I'm using them as a demonstration, just so you know, because you know always about expanding our knowledge. You can use this to clean out, the hearing aid. See, here you go. If there's any gunk in there, if there's any earwax, it would come out. The other thing you can do is use this to change the battery. Why? Because there is a magnet. The magnet picks up the battery. Use it to put it in there, especially if somebody has poor mobility, peripheral neuropathy or anything like that. But if you think about what I just did, that's actually a pretty amazing thing. I'll do it again. I took this tiny magnet right there. What's that weigh? A gram? Less than a gram? It has enough force to lift a piece of metal from the earth. The electromagnetic force created by this battery exceeds the gravitational force of the entire planet Earth. And it doesn't just lift something small like that. Look at this, a fork. Let's see, will it lift it? I think it will. Well, you certainly heard it, and worked earlier. Just barely. It is holding the fork. Can we go even heavier? I don't know. Look at this. This is a knife. Solid metal right there. Let's take a look. Here comes the magnet. Whoop, whoop. There you go. Fork completely lifted, well, barely lifted off the table. Do that again. Prove that I'm not holding it. And I'm not. There we go. All of that's pretty amazing if you think about it. I mean, you have the entire mass of the Earth pulling down with gravity on those metal objects. You have the electromagnetic force created by this tiny magnet pulling up. And yet it is stronger than the entire force of gravity of the Earth. That's really quite amazing. Now, I said I'm not going to get into numbers in this, but I can give a graphical representation. Go back to my handy floor tile. Just for fun, grab another color. We'll do purple. Okay, so imagine that you have a hydrogen atom here. And then right next to it you have another hydrogen atom. And then over here, we're going to pretend that this is the opposite corner of the universe. And over here, there's another hydrogen atom. the amount of gravitation that these two hydrogen atoms, which are adjacent to each other, is equal to the electromagnetic connection between this hydrogen atom and this one, assuming, of course, that one is positively charged and one is negatively charged. So in other words, the scale of the difference in the electromagnetic force and gravity is equal to the scale of the entire universe. It's really quite amazing. Now, where do they get the term electromagnetic force? So that's the last question we're going to resolve today. Clean it up again. This is a porcelain tile. I picked it up at a home improvement store for $1.77. So, this is an economical vlog. So, back in classical physics, before they understood the strong force and the weak force, of course, before they understood really gravity, they did understand two other forces. They understood electricity, which I don't want to spell, but I will. And they understood magnetism. It's a little hard to write when it's still wet, sorry. They knew that those were things. Electricity, current, magnetism, attraction, magnet picking up, you know what a magnet is. Eventually, through experimentation, they realized that that these were really two aspects of the same force. If you take a coil of wire, imagine that's wire and it's going this way, it's going this way. And if you run a magnet back and forth through this coil of wire, what happens? It creates an electrical force that flows through the wire and then can be used to power, power a light bulb. Conversely, they realize the same exact thing happens in the other way. You have a piece of metal. You run a coil through it of electricity. This normal steel now becomes an electromagnet. They realize that electricity and magnetism were the exact same thing, and therefore electromagnetism was born. So that's all today for Hands of Science. If you like what you see, like and subscribe. Stay tuned. We'll be having an episode every week, usually posted on Sunday night, possibly Monday, depending on how busy I am. I do have a real job. All right, thanks for watching, and have a good night.